And then the last section of this unit is on the smart grid, which comes from a selection of slides taken from a course at Illinois. This course is much bigger than I give you the full link here. I just have a few slides to illustrate some of the key ideas. So here the professors in charge of this course. It was a 2010 course, but at the level I'm discussing it, I think the points made are correct. So it notes that the US electricity grid is aged, centralized, very fragile, and it needs to be upgraded with distributed sensors, and centralized cloud computing. And an example was there was a very famous blackout in 2003 in the Northeast, which was due to the failure of the grid. That one failure was cascaded into other parts of the grid, and then the whole thing collapsed. And that affected 55 million people and lost 6 billion, cost 6 billion, and in general, every year 135 billion is lost due to power outages. And of course, the US is well known to have aging infrastructure. It's not just its electrical grid, its roads, its bridges, its buildings are all aging because it actually expanded earlier than many of the emerging countries. So you will get pretty more modern infrastructure in other parts of the world. But the US has made a choice, and it's got aged infrastructure. So trying to improve that infrastructure without rebuilding it all from scratch is pretty important. So smart grids are very straightforward. You take all the collection of items on the grid, all the different transformers and transmission lines and meters and things like that, and you just internet enable all of them and send that data to the cloud, and you use that for the consumers to use their energy more efficiently, for the power producers to know when they have a problem, and to also do selective power offs in an efficient fashion when they're on those days when more power is needed than is actually available. And they do not then have to switch on inefficient sources of additional power quite as much. So this points out some of these features. As I say, here's the grid across the country. We obviously have to worry about security, because if it weren't secure, this IT infrastructure would be used to destroy the grid. We need to make it so that everything is distributed and self-healing. So this is a classic autonomous processing problem, and the IT information is intrinsically reliable. You have multiple sensors, so if one goes down, you can effectively interpolate to find the values from other sensors, and all of this is controlled dynamically. Hopefully it's cost effective. And because it's all software and it's all done by software, it's sort of intrinsically flexible if you write the software correctly. Here's the type of devices you have. It's an advanced metering infrastructure. It allows real-time electrical pricing, accurate load characterization, and outage detections. And so this is a smart meter, which was in California, asked their utilities, for example, to deploy. Here's some more technical device, a health monitor, phasor measurement unit, which measures the electrical health of the system and detects faults early, isolates faulty systems, and prevents unnecessary power outages. This is the type of thing that would have prevented that Northeast power outage, not the original power outage, but just the cascade effect. Here's an example of weather. We know, of course, a lot of the problems with power come from bad weather, and you not only want to predict bad weather, you also want to know when your solar energy will be and wind energy will be effective. And this is the sort of final vision that we want to self-sufficient energy with wind and natural gas, renewable energy, and all of this can be integrated together with this type of infrastructure. So this allows a more richer set of electrical power producers to be supported. So these are relatively clear reasons to do the smart grid, and clearly the electrical utilities are looking very carefully at it. I don't think they're using clouds at the moment, but they ought to be using clouds. So that's the end of this unit, and as we say, there are 24 billion sensors in the Internet of Things by 2020. They all ought to be linked up to the cloud, and that will provide them. The cloud will give them enormous performance, and the 24 billion devices will give a lot of use for those clouds. Thank you very much. That is the end of this unit.